So hello everyone, welcome. I welcome everyone today in this particular Palo Alto Firewall demo class. So before going into the demo, let me just tell you, we are basically starting Palo Alto Firewall plus F5 Ltm combo wedge. That wedge we are starting from 23rd of July, and it's a weekends batch basically. So your classes will happen Saturday and Sunday, starting from 9 a.m. to 11 a.m. as per Indian Standard Time. Fees for both Palo Alto and F5 Ltm is 10,000 INR. If you are interested for this particular training, you can basically contact into these numbers. So here is our numbers. This is my website, sianets.com. So if you will Google it, you will get our websites. And if you want to see the course content, what I'm covering, you can click on Palo Alto Firewall here, and you will get this page. In this page, if you will go down, at the bottom you will get the download the syllabus. So from here you can able to download the syllabus what we are covering. This is my application. So we do have a web application, and this application is also accessible over the web browser. Here we have some courses. So if you want to check out our other courses like FILTM, GTM, ASM, Palo Alto Advanced Stack, Python, FortiGate, Checkpoint, you can basically also purchase the video with training from here. We do have a two YouTube channel. First YouTube channel name is NST Firewall. Here you will get the lots of videos on Palo Alto Firewall. We do have another YouTube channel with the name of Is Ssl Inspirational Academy. Here you will get lots of videos on F5 technology basically. So this is about ourselves basically. Now, let me just tell you what are the things generally we will cover or what kind of supports you will get from us. So this is a 32 plus hours of training. So 32 plus hours of Palo Alto training and 32 plus hours of your F5 Ltm training. You will get the lifetime interview support. You will get the lab workbook. You will get the recorded videos with the access of lifetime. We will also help you building the lab on your laptop. If you don't have good laptop, so for Palo Alto, you need a laptop of with 12 GB of RAM. If you don't have a good laptop, then we will help you building the same lab on Google Cloud platform. For that, you just need one credit card with the limit of 75,000 INR. If you have that credit card, Google Cloud will give you 300 USD as a free credit. That credit we can use for the lab purpose. It's a weekends batch basically. As I have mentioned, your classes will happen Saturday and Sunday starting from 9 a.m. to 11 a.m. We will also help you in a discussion. So let's suppose you are having any kind of issues in your office environment, or you are having any kind of issue in your lab environment, you can basically discuss these things as well with us basically. You will also get the mock interview support from our side. So these are the things which we cover now. Let me just move towards the course content. What are the things I am basically covering in this particular training? So I'll start from here. So I will basically start your course by discussing the platform and architecture. In platform, basically, I will explain you what are the hardware models we are having on Palo Alto, what are the virtual what are the VMs we are having for Palo Alto Firewall, how we can basically install these VMs into multiple cloud environments basically. So all these things I will discuss, and I will also discuss here most important thing, which is architecture. And Palo Alto architecture is known as SP3 architecture, single pass software and parallel processing hardware. So this architecture we will discuss. What is the single pass architecture, how this is implemented, on which Palo Alto model this particular architecture is applied, everything we will discuss. And after that, I will just move towards your flow logic, where I will discuss packet flow, the detailed packet flow of your Palo Alto firewall. When any packet enters into the Palo Alto, how Palo Alto firewall basically process these particular packets. What are the different processing stages we are having basically. So we will see everything. If you are good with this particular flow logic, you can able to troubleshoot the Palo Alto firewall easily. You can able to troubleshoot any kind of connectivity related issues basically. And after it, I will discuss your initial configuration, how we can access the Palo Alto firewall first time. So how we can do the initial configuration using CLI. What are the commands we can use? We will discuss here everything. I will also discuss here configuration management, where I will tell you how basically we can manage the configuration, how we can save the configuration, how we can import, how we can export. Everything I will cover here. And after that, I will just discuss your licensing and software. What type of license we are having in your Palo Alto firewall? What is software updates? How we can basically download these updates by using graphical user interface, by using CLI, how we can schedule these updates basically. And in licensing, because whenever you will receive a Palo Alto firewall in the production environment, what you have to do? You have to register the Palo Alto firewall with the support portal by using the serial number, by putting the address of that device. Then how we can basically do all these things. Now how we can apply our auth code into the support portal, then how we can download the license keys, and how we can upload these license keys into the Palo Alto firewall. What are the different ways we are having to license our Palo Alto firewall? So I will discuss all these things basically in detail. And after that, I'll just move towards account administration, how we can create a multiple accounts for L1 engineers, for L2 engineers, for L3 engineers, and how we can basically assign the different admin roles basically. So we will discuss in detail. Then I will also explain here how we can use your Active Directory user, how we can use this AD users, how we can use the radius users on for logging purpose on your Palo Alto firewall. So how we can integrate these things, we will discuss that part here. When we will complete with this, I'll just move towards your interface configuration. Here I will tell you how we can configure the interface by using CLI, by using graphical user interface. What is the concept of security zones, how we can create these zones by CLI, using CLI, using graphical user interface. What are the different type deployment modes we are having on Palo Alto 5, like layer 2 deployment, layer 3 deployment, virtual wire, and tap mode deployment. We will discuss all of them. I will also explain you the concept of sub interfaces on Palo Alto firewall. Then I will just move towards your DSCP. In DSCP, we can configure three things: DSCP client, DSCP server, and DSCP relay agent. So how we can configure your Palo Alto firewall basically with DSCP relay agent, DSCP clients, and DSCP server. And I will also explain what is the concept of virtual routers, because in Palo Alto firewall, if you want to configure any routing, then you have to know the concept of virtual routers, how we can basically create these virtual routers, and after how we can configure the routing here. Let's suppose you have a multiple virtual routers, then how we can basically allow the communication between multiple virtual routers. What are the use case for this? So I will discuss that part. And after that, I'll just move towards the main topic of your Palo Alto firewall, which is security policies and net policies. Here, basically, I will explain you how you can configure the security policies, how we do the administration on the policies. Basically, I will also discuss here what is net, what is source net, what is destination net, what is U-turn net, what are the different use cases of net basically. So I will discuss almost all the use case, because I used to take around 3 classes for security policies net, where I used to cover all the combination of your net and all the combination of your security policies. And after that, I'll just move towards the app ID. So from here, basically from app ID, I will start the layer 7 features of your Palo Alto firewall, where we will discuss app ID overview. In overview, basically, I will tell you the operation of application identification, because when packet go inside the application engine, And which engine basically do the application identification on Palo Alto firewall, which basically chip. So inside Palo Alto Firewall, we have some chip. So the chip which name is Jaguar chip. This chip is responsible for doing your app ID operation. And there is a one algorithm known as DFA. This algorithm runs on this Jaguar chip, and these things basically, these two things take care of your app ID. Now we will discuss all the flow. Here we will discuss what are the application signatures we have, what is Palo Alto Applipedia, everything I will cover with practicals basically. After I will create here application groups and filters where I will create a risk level applications, social media related application or media streaming application, and I will apply the multiple actions on them basically. So we will discuss app ID in detail, and after that I'll just move towards the content ID overview, where I will discuss what is antivirus protection profile, what is anti-spyware protection, what is vulnerability protection. Here basically I will basically try to download the live antivirus, basically live virus from the internet, and we will see how my Palo Alto firewall protecting these virus. In vulnerability protection, I will basically launch the attack. I will try to exploit one of the vulnerability by using my Kali Linux machine. So we will see here live attack and how my Palo Alto firewall is preventing us from these kind of attacks basically. And after that, I'll just move towards the URL filtering, which is the most important feature of your Palo Alto firewall. So in URL filtering, I used to discuss here lots of details basically. What are the different types of URL filtering solution is offered by Palo Alto firewall? What are the different type of license we need for URL filtering? What is the management plane cache for URLs? What is data plane cache, right? What is cloud lookup? Everything I used to cover in detail, because this solution or Palo Alto basically offers two solutions. First solution name is PanDB, and second one is Bright Cloud. PanDB is is the solution which is managed by Palo Alto itself. Bright Cloud is a third-party URL filtering solution. So we will discuss PanDB in detail, because this service or this particular cloud is hosted into 5 regions across the globe over the AWS environment. So we will discuss how my Palo Alto firewall create a connection with the nearest data center or with the nearest PanDB cloud, how the election process happens, everything we will discuss in detail by looking into the logs of your device server daemon basically. I will discuss here external dynamic list, how we can use the EDL feature of your Palo Alto firewall for blocking the URLs. And after that, I'll just move towards your file blocking policies, how we can control, means how we can block the upload download of different types of files. What is wildfire? I will discuss the actual wildfire operation. What is security profiles, file blocking, what is wildfire, everything we will discuss here in detail. When we will complete with that part, I'll just move towards the zone protection and DOS protection basically. In zone protection and DOS protection, you will see here, I will launch the live attacks from my Kali Linux machine. I will launch the SYN flood attack, UDP flood attack, ICMP flood attack, IP spoofing attack, and we will see how I basically I can consume all the session table of your Palo Alto firewall. And after applying this zone protection and DOS protection policies, how Palo Alto firewall providing the protection to us basically. So we will see all these things in detail. When we complete with that, I'll just move towards the SSL decryption. Where what is SSL decryption basically? So here I will first explain you the SSL handshake, the actual SSL handshake. Then I will also explain you here what is outbound SSL decryption, what is inbound SSL decryption, what is SHS decryption basically. What is certificate management? Here we will discuss what is root CA, what is intermediate CA, what is the end user certificate, everything we will see in detail basically. And here I will also explain you the actual implementation of outbound SSL decryption with the help of SSL handshake on Palo Alto firewall. What are the parameters is modified by the Palo Alto firewall, because I have seen in the market people have lots of misconcept information here. Basically lots of wrong information they are having, like they used to say Palo Alto used to create a proxy, it used to do the proxy basically, but it's not like that. There's a lots of stuffs is happen in the backend. Here I will also tell you how, because in Palo Alto 5 we are having a dedicated SSL engine basically, and this engine will process these packets. Now how it will process these packets, it will store that information into the FPTCP segment. Now we have to discuss what is this FPTCP segments. One FPTCP segment is equals to 2 software buffers and 1 hardware buffers. What are these buffers basically? All these things I will cover in detail basically. When I will complete with that, I will basically start your user ID, where I will tell you the actual scope of user ID in Palo Alto Firewall, how we can basically implement user ID in your Palo Alto Firewall. We will see the actual implementation of user ID. In user ID, I will cover your Active Directory integration, how we can achieve user to IP mapping, how we can install the user ID agent. And when I will complete with that, I will also explain you here group mapping, how we can create the group mapping. I will also explain here authentication profiles, authentication sequence, and after that, how we can use these particular users or groups into our security policies. So all these things I will cover in detail. And when I will done with that, I will just start your IPsec site-to-site VPN. In IPsec site-to-site VPN, I will cover your phase 1 exchange, phase 2 exchange in detail by using the IKE version 1. In IPsec tunnel, basically, I will discuss what is IPsec tunnel, which is what is phase 2, what are the things basically we are what are the basically parameters they will exchange in phase 1 and phase 2. Here I will also discuss in IPsec VPN. In Palo Alto Firewall, there are multiple daemons basically involved. I will discuss the use of each and every daemon. Like first daemon is IKE MGR. What is the use of IKE MGR daemon? Then we have a key MGR, key manager daemon. Then we have a tunnel D daemon. We have a MP relay daemon. All these daemons I will discuss in detail in your IPsec. Apart from this, basically, here I have mentioned around 13 use case of your IPsec VPN. Here I will use to cover few of them. Maybe 2 or 3 use cases I will try to cover in your class. And for the remaining use case, we will basically give you one voucher, so you can basically get these remaining use case from our application. So it will cover almost all the possibilities of IPsec VPN in your Palo Alto firewall. And when I'll complete with your IPsec VPN, I will start your Palo Alto Firewall Global Protect, which is a remote access VPN solution from Palo Alto. Here I will explain you the connection flow, because I can see when we used to connect with the Global Protect, I say it between your client machine or between Global Protect agent and your Palo Alto Firewall, they have created around 16 SSL tunnel. So these 16 SSL tunnel we will discuss in detail. What is the exact connection flow? Here I will also tell you how you can decrypt your HTTPS traffic. How you can decrypt the HTTPS traffic. I will tell you the ways to decrypt that traffic. And by after decrypting these packets, we will verify these particular connection flow. If you know the connection flow, then only you can able to troubleshoot the global protect related problems. Otherwise, you will not able to do it basically. One more thing I missed in your IPsec VPN, I will tell you how we can decrypt your, because if somebody is aware of the VPN, so if I will use main mode in phase 1, then you will see they have exchanged 6 messages, right? And they have a phase 2, which is known as quick mode, they will exchange 3 messages, right? So total, they will exchange 9 messages. So starting from message number 5, 6, 7, 8, 9, they are encrypted, right? I will tell you the ways how we can decrypt these messages. And after that, your ESP packet, it will basically encrypt your actual data. I will also tell you the way how we can decrypt these ESP messages. as well. And I because I know the ways, I will run the debug on Palo Alto Firewall at the global level, at the dump level, and I will show you how we can take out the keys, because in BPN there are the multiple session keys, SKID-E, SKID-D and A, right? These keys they will basically use for decrypting these messages. Encryption keys, their authentication keys there. I will tell you how you can take out these keys and how you can basically decrypt these messages as well. In your global protect, I will basically explain you all the four type of deployment of your global protect VPN by using user logon. Then we are having one more method, on demand, then pre-logon, then on demand, pre-logon, then user logon. So all these four deployment I will cover. When I will done with that, I will also give you the idea how you can basically configure the syslog server, how you can configure the net flow server, what are the log types we are having, what are the dashboard, basic logging, basic reporting. I will explain you all these things. On Panorama, I will not take any session. We will give you one voucher, so you will get our 7 hours of Panorama training just in 300 INR if you will enroll for that course. I will also cover your high availability, where I will cover active passive high availability, active passive configuration of active passive, then active high availability. In active high availability, I will cover all the deployment modes. So because in active HA, we are having floating IP HA lab, we are having R float share HA lab, mixed mode HA lab. I will cover all of them. Apart from this, I will also run one troubleshooting webinar where I will explain you what is packet filter, what is packet capture, what is flow basic. Because when we run the flow basic, this is the advanced mode of troubleshooting in Palo Alto Firewall. I will tell you how you can run these flow basic and how you can analyze the logs. Then I will also explain you here TCP dump, how you can run the TCP dump to capture the management related traffic. So this is all about the course content, guys. If you have a query, you can basically contact on this number. This number is owned by me, so you can directly discuss the things with me as well. Now what I will explain you, let me just give you one more idea, guys, or let me just tell you what are the lefts I'm using basically, or what are the left topology I will use during the training. So in the training, basically I will use this particular topology for almost around 70% lefts. I will able to simulate by using this particular topology, where I have one Palo Alto firewall, I have a dedicated management network of Palo Alto firewall. I do have a outside interface, which is Ethernet 1x1, which is connected with my home internet. Here I have one Kali Linux machine. This machine I will use for launching the attacks, and I do have one more outside R1. So I will use this particular router for launching some kind of advanced basically attacks by modifying the IP header information. I do have Ethernet 1x2 interface. This interface I will use as an inside network, where I have one Linux machine and one Windows machine, and I will use these machines as a test PC. And I do have one more interface, Ethernet 1x3, which is connecting my DMG. In DMG, I have these particular servers, where in these servers I'm running SHS, I'm running Telnet, and I'm running HTTP services. So basically, I will configure your different types of net and everything for providing the access of these servers to the outside peoples. So this is the one topology which I'm gonna use. Apart from this, I will use this topology as well. Not this one. I will use this particular topology for your IPsec lab, where I have Palo Alto Firewall 1, Palo Alto Firewall 2, and Palo Alto Firewall 3. 3 Palo Alto firewalls, 1 Cisco SA firewall. So by using this topology, we will able to simulate all the IPsec related scenarios basically. And here you will get everything. I will explain you how you can basically configure this entire topology, and after that how we can run, how we can configure the VPN between your head office and branch office. So such kind of things I will cover here. Now, apart from this, I will use this particular topology for simulating your HA lab, where basically we have a firewall 1 and firewall 2. We have an outside network and inside network. This particular lab we will use for performing your HA practicals, active passive and active active. Both practicals can be done by using this topology. Apart from this, I will also use one more topology, which is this one. This topology I generally use to explain your path monitoring, or you can simply say ISP redundancy, right? We have a two ISPs here. So I will basically explain you here concept of path monitoring. I will explain the concept of PBF, policy based forwarding. This is also known as PBR, policy based routing. And I will also use this particular topology for explaining your ECMP concept, equal cost multipathing. And I will also use this topology for explaining the static routing, how we can configure the static routing on your Palo Alto firewall. So these are the lab topology which I'm gonna use throughout your sessions. Let me close this lab. Let me just see if I have any other one. I also used to basically use this particular topology as well for performing some of the practicals, because I needed some external machines and some internal machines for in your user ID and in your global protect, right? So that time I used to basically use these particular machines for doing these things basically. Okay. So this is all about the lab topology which I'm gonna use in your classes now. Guys, I will explain you the packet flow today. So, but here I will just, because generally when I used to explain this packet flow, I needed around minimum 2 hours to basically explain you the entire packet flow of Palo Alto Firewall. But here I will give you the glimpse of it. But apart from this, I will also tell you the advanced stuff on Palo Alto Firewall, how Palo Alto Firewall component is connected and everything. Okay. So let's discuss here. So guys, always remember, if I'll explain the block diagram of your Palo Alto firewall, so in Palo Alto firewall, if you will see, or let's do like that. I will not use this one, use here. Let me draw the things here. Okay, cool. So generally, first I will cover the block diagram of your Palo Alto firewall. What are the things we have inside the Palo Alto firewall, or we will discuss the internet component of your Palo Alto firewall. Okay, so in your Palo Alto firewall, basically, if you will see, these are the interfaces stack generally, right? We have a data interfaces here. So let's suppose your interface starting with Ethernet 1x1 till Ethernet 1x8. Let's take an example. We do have some other interfaces here, starting from Ethernet 1x9 till Ethernet 1x12. So guys, always in your Palo Alto file, this particular interface stack, it has a direct connection with one of the chip which is known as Marvel chip. And here I will draw one more chip which is known as Petra chip. So these are the two chips generally you will see in your Palo Alto firewall, and they are directly connected. So your interfaces always directly connected with this particular chip. Now you can mention why we have this Marvel chip and Petra chip. So guys, just remember one thing. This Petra chip we use for connecting the SFP plus port. So if in your Palo Alto 5, if you are having SFP plus ports, these ports always connected with the Petra chip basically. And this particular Marvel chip is used for connecting the copper ports. So if you have a copper ports, these ports will have a connectivity with the Marvel chip. Now, after this chip, Palo Alto have one more chip now. So that chip name is, so in low end boxes, basically you will get the chip which is Liger. Low end boxes, I can say 2000 series devices. These are the pretty old box, guys, Liger chip. And if you have a high end boxes like 3000 series, 5000 series boxes, or your 7000 series boxes, you will get the Tiger chip. This Marvel, it has a direct connection with this chip like that. Petra also have a same connection with this chip, and this Liger or Tiger chip is known as network processor, because in Palo Alto firewall we have a network processor, or this network processor is also known as session offloader. So guys, if you will see, Palo Alto firewall can able to do the session offloading, and session offloading is done by the this particular processor. This is a FPGA, field programmable gateway array. Now this Marvel chip and Liger and Tiger chip, they have a connectivity with each other, right? These links is known as joy links. Why I'm explaining this thing? Because if you know these things, and if there is any problem with your hardware, if you know these things, then only you can able to run the hardware test, and you can also able to check the counters there, error counters basically, and you can able to troubleshoot the issue if there is any problem with the chip level. Now this Liger and Tiger chip, it has a direct connectivity with one of the chip is known as Octeon chip. It has a connectivity with each other through the joy links. This Octeon chip is known as data plane CPU, guys. This is the data plane CPU of your Palo Alto firewall. And after that, this particular data plane CPU or this Octeon chip, it has a direct connection with one of the chip is known as Jaguar chip. This chip is also a FPGA. Now guys, remember, in your Palo Alto firewall, we have two things, your application identification and your content identification. These things basically take care by the Jaguar chip. This Jaguar chip also known as signature or pattern match processor. Signature match processor or pattern match processor. This chip is also known as pattern match processor, signature match processor. In this chip, basically, we have two types of algorithm. First algorithm name is DFA. DFA algorithm is responsible for your app ID related operations. And we have one more algorithm known as AHO. Now AHO is replaced with the PS scan starting from PanOS 9. PS scan. Now this PS scan is responsible for your content ID, means your antivirus protection, your anti-spyware protection, your file protection, your wildfire, your URL filtering. Everything is done by the PS scan algorithm now. Okay. So this is the data path, we can say, of your Palo Alto firewall, or block diagram of your Palo Alto firewall. Now, if I'll talk about the packet flow in your Palo Alto firewall or life of a packet in PanOS. So if you want to understand the packet flow of your Palo Alto firewall, first you have to understand the different stages of your packet flow in Palo Alto firewall. So if I mention here, first state is known as ingress stage. Then second stage is flow lookup. Flow lookup is also known as session table lookup, basically flow lookup. Then third one is slow path. Slow path is also known as session setup stage. Then we have a fourth one, which is fast path. Fast path is also known as layer 2 to layer 4 processing. Then we have app ID. Then we have content ID, app identification, then content identification. And seventh last stage is your forwarding stage. So these are the packet processing stage we are having in your Palo Alto firewall. Now, if you want to see these stages, you can see this is the Palo Alto firewall diagram. This is the packet flow diagram. So we have an ingress stage, right? Then we have a firewall session lookup. Then we have a layer 2 to layer 4 firewall processing or fast path. We have a firewall session setup or slow path. We have a app ID, app identification. Then we have a content ID. And at the end, we are having forwarding stage or egress stage, right? So these are the packet processing stage we are having in your Palo Alto firewall. Now, if I'll write down this thing, if I'll draw one diagram, let's suppose this is my inside machine on my network. This machine have a connectivity with my Palo Alto firewall. So this is my Palo Alto firewall. And I do have one of the server here, maybe server one. This machine, let's say, having IP address 10.1.1.70, and this server having IP address 10.2.2.70, right? This is Ethernet 1 by 2. This is Ethernet 1 by 3. Let's suppose I have this kind of setup. Now, this is this server running web service on TCP port 80. So if this is the case, then how the communication happens between these guys? So this PC, he will send first packet. This packet is always a TCP SYN request. TCP SYN in case of TCP connections, right? Now when this SYN request is received by the firewall, now how my firewall process the SYN packet, right? So if I write down the processing of this TCP SYN request by Palo Alto firewall, what it will first put this packet into ingress stage. Then, because you know it's a first packet, right? TCP SYN always a first packet in case of TCP, which means this packet now go for the flow lookup, but this time flow will not found, right? There is no flow, there is no any session, right? So what it will do, if there is no flow, then this packet go towards the slow path or connection setup state. And after that, from slow path, now it came to fast path. And after it will directly go into the forwarding stage. Now, can guys anyone write on a chat why this packet will not go through app engine and content engine? Chat is open, guys. Anyone know why this packet will not go through the app ID and content ID here? Anyone aware about that, guys? Yeah, that's correct. So somebody has answered TCP SYN, because TCP SYN, SYN plus ACK and ACK, these three messages is not having any kind of layer 7 content basically. If they are not having any kind of layer 7 content, then which means you will not get any, these packet will not go through your app engine, right? That's correct answer, guys. Okay. So that's why this packet will not go through the app engine now. Now, Just think of it. When this firewall receive this packet, it will basically process again these 5 stages. Now, if something is breaking, what you have to check? You have to check these 5 stages and you can able to troubleshoot your problems easily, right? Now, and after this, this send reaches here. Now this server, he will send SYN plus ECK. This is the second packet. Now SYN plus ECK, when my firewall will receive the SYN plus ECK message from this server, what will happen? If I write down here TCP SYN plus ECK processing, how my paloalto process this packet? So it will process like that. Your ingress stays, then your flow lookup. This time what happens? This time it will find the flow, guys, because it has created the flow when it has received the SYN request. Now let me tell you how they will create the session table, how it will do the flow lookup, guys. Just remember, in Palo Alto firewall, what will happen? It will basically create the session for every session. Basically, it has create the session and it will associate one session ID. What it will associate one session ID? So let's suppose it has associated one session ID which is 100 with this particular flow. Now in this session, what it will store? It will store the source IP address, destination IP address, source port, destination port, layer 3 protocol, and your zone details. Or here I can mention ingress zone details, the zone where he has received the packet. So what is the source IP? Source IP is 10.1.1.70. Destination IP is 10.2.2.70. Source port, it will take any random port. So let's say it has taken 1025. Destination port is 80. Layer 3 protocol number for TCP is 6. And ingress zone, let's suppose this interface is a part of inside zone and this enter is a part of DMZ zone. So it will put here inside zone. Now these are the 6 tuples it will have in the session table. Now what it used to do, it will collect these 6 tuples. It will run here MD5 hash. It will run the MD5 hash algorithm and what? It will generate one hash value. That hash value is known as flow key. And after that, what it will do, it will store this particular flow key into the database called as MongoDB database. So this is the database which is used by the Palo Alto firewall in backend basically. So it will happen like that. Now guys, there is so many things in your session, because when I used to cover the life of a session, there is a multiple stage we are having. So but I will not go in that much details. When it will create a session, it will create 2 flows, client to server and server to client, guys. Okay. So when he received the SYN plus ECK message, this time it will match the flow. So what it will do, it will bypass the slow path. Now your packet go towards the fast path. And after that, forwarding stage. So like that, it will basically process SYN plus ECK. And after that, it will basically send the ECK message. Right? ECK also process according to this only. Now, when they will exchange these 3 messages, your TCP is established now. And after that, what it will forward the next packet, which is known as HTTP GET request, right? Now, this HTTP GET request is processed by my Palo Alto firewall like that. What? It will process at ingress stage, then flow lookup. Flow will be found, right? So this packet now it will forward towards fast path. Then now your packet go towards the app engine for app identification. And if layer 7 inspection is enabled, then it will go towards your content engine and your forwarding stage. So like that, it will process the packet basically. So these are the different states. Now, what are the things it will do into these states? Let's discuss these things, guys. So for that, today I will basically discuss this particular packet flow diagram because it's a small diagram, guys, and it has not covered all the information because Palo Alto launched this particular diagram around in 2010, and today is 2022. It's a long story now, right? If it's a 2020, which means they have added lots of extra features. So the latest diagram or latest packet flow diagram of PanOS, I will discuss in your live classes according to PanOS 10, guys, because for that we don't have any diagram. I have created that diagram by verifying the logs on your Palo Alto firewall, because whenever you used to run the advanced debugs, basically we used to get these kind of logs. This is how it will process the packet. These are the live logs I have collected from my Palo Alto firewall. So everything I have basically included here. Okay. So this thing I will cover in your live classes basically, because they have introduced lots of new things in your latest diagram. Okay. So here, when my Palo Alto file receive a packet, what it will do? It will extract the layer 2 information, layer 3 information, and layer 4 information, which means layer 2 information is your source MAC address and destination MAC address, your ether type, all such kind of information it will extract from your layer 3 header, and sorry, from layer 2 header. From layer 3 header, it will extract the source IP address, destination IP address, IP version, all these details. And from layer 4, it will extract the source port, destination port, protocol, all these things. And it will also, because my Palo Alto firewall know he has received this packet, let's say in Ethernet 1x1 interface, which means it's this interface is a part of outside zone, right? So it will basically get the zone details as well, the ingress zone details. And sometime if my firewall is receiving the fragmented packet, so what it will do? If he is receiving the fragmented packet, which means it needs to do the IP reassembly. So it will do all these things in your ingress stage. Apart from this, it will also check the errors here, ingress process errors, which means it will check your headers, layer 2 headers, layer 3 headers, and layer 4 headers are properly formatted or not according to the IP stack. If there is any problem with these headers, what it will do? It will drop the packets here right away if there is any problems at the header level. Otherwise, your packet go towards the IPsec VPN or SSL VPN. So let's suppose your packet belongs to the IPsec VPN or SSL VPN. In that case, what my Palo Alto file will do the decryption first. It will get the actual IP header and it will again put this actual IP header into the ingress packet processing. If everything is fine in your ingress stage, now guys, let's suppose your packet is dropped at the ingress stage, which means if your packet is dropped at the ingress stage, this particular log you will not able to see into your traffic logs in the monitor tab. Means if you don't know the advanced debugs commands, you cannot able to identified where your packet is dropped by the Palo Alto firewall. Here basically we need to run the flow basic commands to check if this packet is dropped here or not. Okay, now after passing this ingress stage, your packet go towards the flow lookup. It will start doing the flow lookup. So what it will do? As I have mentioned, it has extracted your layer 3 information, layer 4 information, and layer 2, right? So from layer 3, it will get source IP, destination IP. From layer 4, it will get source port, destination port. It will also get the layer 3 protocol number and ingress zone, right? So what it will create the flow key. Now it will use this flow key to do the lookup into the float table, which is stored into MongoDB database. If there is a match, what will happen? If there is a match, then it will go towards the fast path. If there is no match not found, then it will go towards the slow path. Now in slow path, basically it will do the here lookup, which is routing table lookup. Now it will do the routing table lookup. If it will perform this routing table lookup to get the egress interface, guys, to get the egress interface and zone details. Basically, it will always do the routing lookup to get the egress interface or zone details. Just remember here, if you are using policy based forwarding, then it will always first check the PVF policies first. If you don't have PVF policy, then it will check the routing table. So PVF will take the higher precedent here. Okay. After that, your packet go towards the net policy lookup. Here, what it will do, it will just evaluate the net policy. Means it will just identify this is the net rule which is matching. That's it. It will not do the address translation. Address translation is applied here, guys, in your first path. Okay, just remember your address translation is applied in the first path. Okay, here it will just evaluate the net policy lookup. Now just remember one thing. If your packet is matching the destination net, in case of destination net, because your final egress interface may change, right? So what it will do in case of destination net, it will do the lookup again into your routing table. Okay, and after that your packet go towards the firewall security policy lookup. If your policy rule is having the action which is deny, what it will do, your packet will be dropped. If your packet is dropped by the security policies, you will get the log into your monitoring tab. Basically into the traffic monitor, you will get the logs. Otherwise, if your packet dropped here, let's say at the routing level, you will not get any log. If your security policy is allowing the packet, what will happen in that case? It will create the session and it will store this particular session. What it will create a session, it will store this session into the session table. So your session installation happens here after successfully passing the slow path, guys, just remember. And after that, your packet go towards the layer 2 to layer 4 processing, which is first path. You can see the arrow here. Now if you are using SSL decryption, now your packet will be go inside the SSL engine and your packet will be decrypted. So first, what it will do, it will store this packet into FPTCP segments, your layer 7 info, and it will start processing this thing. We have a dedicated SSL engine. Okay, if session app is identified, no, in that case your packet go towards the app engine, where it will match first app override policies. So we can also write the app override policies. So basically it will bypass the application checks for that particular application. It will do the pattern based identification and everything. This part we will discuss in detail in our classes. Okay, so here your appli identification happens, and after that your packet go towards the content ID, where in content ID it is basically running some decoders, protocol parsing, decodings, all these things happens, and it will also match. It will send this packet with the various signature database for different features like antivirus, anti-spyware, URL filtering, all these databases. And what it will do, according to it will basically take the action. So if your packet is containing any kind of virus, or if it is having any kind of malicious code, what it will do, it will drop the packet here. It will discard the packet here. If everything is fine, then your packet, if decryption is happening, then your packet is re-encrypted here. And now your packet go towards the forwarding stage, which is egress stage. Now in forwarding stage, basically, what here your layer 3 packet is formatted properly. your quality of service is applied here. If we are using quality of service, if fragmented is applied, then IP fragmentation happens here. Your layer 2 lookup is also done here. Your ARP lookup, everything is done here. If if this packet belongs to IPsec VPN and all, then your tunnel resolution and packet encryption is also happens, and after that your packet basically send out through the firewall. So guys, this is the small, we can say, life of small packet flow. Generally in your live classes I used to discuss in detail, so let me just tell you the latest diagram so you will get some idea. So let me just find it out. So this is the life of a packet. This is the advanced diagram, guys, where I have included everything. Basically, first we will discuss, because here also in block diagram I also need to discuss lots of information, but due to the time I don't have that much time to cover everything here. So that's why I have keep it very short. So this is the latest packet flow diagram, guys. Okay, they have introduced the DOS block table here, how they will process the IPsec VPN packet, how SSL VPN, how GRE packet, how SHS packet they will process here. We will discuss how the flow lookup happens for TCP, for UDP, for ICMP, for IPsec packets, for GRE packets, everything, because these protocols, your IPsec, GRE, they don't have source port and destination port field, right? How these packets will be processed. And after that, in your silo path, there is a lots of new thing: zone protection profile, TCP state checks, your user to IP cache, then application cache. And after that, your routing lookup happens, then net policy lookup, then authentication policies, DOS protection policies, right? And after that your security policy come in a picture, and after that your session is created. Then tunnel encapsulation is also started, the TCI policies lookup. So in your live classes I will discuss with this diagram, because there are lots of stuff they have introduced in your application as well. So this is the latest diagram, guys. So I used to discuss this diagram because I need lots of time for this one to cover. That we will discuss different life of a session, different stages like init, opening, active, discard, closing, closed, free, what's that, how they will create a flow key and everything, right? We will discuss all these things in your actual classes. So the guys, this is all about your demo for today, and now I'm just stopping the recording.